you're on Earth, and I'm going to give you examples of calculations that you'll be doing. You won't do all the calculations I do, but it'll be like them. So, before I forget, at the end, there's a couple of questions that try to trick you. And like, it'll ask you, what is the mass of a 1 kilogram object? Mass is measured in kilograms. So, if it asks you for the mass of a 1 kilogram object, it's 1 kilogram. I just gave it to you. So, don't overthink this. Alright, so here we go. All these objects right here are on Earth. And your Google form starts you out finding the weight and the masses of these objects. So I'll do a couple of these. So for object A, it says the mass is 1. Anytime you're finding weight, because weight is caused by gravity, you will use acceleration equals negative 9.81, like we've been using for gravity. So that's what I've done. Weight is a force, so we'll use F equals ma. And so I'm saying the force of weight of object A equals the mass of A times A. So that's just F equals ma, just with some extra little letters on there saying that it's weight and object A. So F equals ma, so m is 1, and A is that negative 9.81. And to find the weight, I find the force. Weight is the force. 1 times negative 9.81 makes negative 9.81 newtons. And that's the weight of object A. It's always down, because that's the way weight goes. It's always down. And as long as you use negative 9.81, then you'll be fine. All your weights will always be down because you used the negative number to calculate it. Let's use one of these to find mass. So over here it gives you the weight of object D on Earth, which is negative 12 newtons, 12 newtons down. So when we plug that in for force is weight, we're looking for mass, and the acceleration, as always when you're looking at weight, is negative 9.81 meters per second squared. So in order to find mass, we'll divide both sides by negative 9.81. That's a long negative sign. Boom, boom. 12 divided by negative 9.81 is 1.22. Now, mass in kilograms is the amount of matter that you have. Weight is gravity's effect on your mass. Gravity pulls your mass down, and then it causes your weight to read a certain number. Just like I was doing on the example with the when we all did our weights in that Exploratorium website, where your weights on different planets. If you go to another planet, it's got different gravity. Your mass is the same when you go to that planet, but your weight is different. If you go to Mars, Mars doesn't have as much gravity, so you're not pushing down as hard with your mass, because gravity's not pushing you down as hard. Mars doesn't have as much gravity. Oh, I could have got that right. That's in kilograms there. So when the mass of object D is 1.22 kilograms, when it goes to Saturn, its mass will still be 1.22 kilograms. And when it goes to this made-up planet, its mass will still be 1.22 kilograms. And same with all these others down here, planets, this made-up planet and that made-up planet, down the page. And now that we have its mass, we can use the acceleration due to gravity on Saturn to find its weight. So its weight is a force, so we'll use F equals ma. So we'll do F equals ma, and I'll plug in m and a and multiply them. So the mass of object D is 1.22 kilograms. And the acceleration due to gravity on Saturn is different from Earth. It's negative 9.1. And 1.22 times negative 9.81. I just did this, and I can't remember what it's 11.1. There we go. Oh, that's negative 11.1. And that's weight, so it's in newtons. Another thing that some of these will have y'all do is it'll have you solve for acceleration for on some of these planets, like on this mystery planet. We need to figure out the acceleration due to gravity. So if we know the weight is 25, we can use F equals ma. So if that's the weight, I plug that in for F. So for F equals ma, let's see, we're not worried about these. We're just doing this part. The force is negative 25. The mass is 1. And we're looking for the acceleration due to gravity. So negative 25 equals 1 times what? A is going to be negative 25, but if we want to, we can do divided by 1, divided by 1. Negative 25 divided by 1 makes a negative 25, and those cancel, so it says equals A now. That's a 5. It's acceleration, so that's in meters per second squared. So yeah, hopefully this isn't too easy. It's just F equals ma here, just a formula with 3 little letters in it. We will, we've got our free body diagrams and we've got this formula. We're about to do some calculations with friction over the next couple days. But hopefully this is all right. When you put your answers in the Google form, make sure that you put a space between the number and the unit. So if it's like 9 newtons, say 9 space newtons. Or if it's 14 kilograms, say 14 space kilograms. And watch for those trick questions. If it asks for mass and it gives you kilograms already, then it's kilograms are mass. So just put the number of kilograms it gave. Y'all have any questions about this? All right.